We have a great speaker which doesn't understand Czech, and he will present in English. So uh, please welcome Ringo. He's from Pulumi, surprisingly, and it will be. And we will have very exciting 40 minutes presentation about the technology. So from Pulumi, of course. So enjoy. Stage is yours.
Thank you. First of all, Pavel, thank you for having me. Thank you for inviting me. It was quite a trip for me, but still glad to see you all. Opening question for me usually is then, who used or is using Pulumi already? 2, 3, okay, good. But I'm also glad that a lot of people aren't using Pulumi yet, because that's also where I can then start and show off, hopefully, when the power of Pulumi, when you go out of this session, that you're sort of triggered to give it a try. And that's the least I can do. Yeah? But first of all, a bit of context. We've seen all of this in a number of marketing slides and all that on bigger conference. But in a way, still, yes, I do want to highlight a bit why we chose certain things in Pulumi. Because somewhere around, let's say, here, yeah, we see that a lot of other companies, besides the cloud providers, besides technical service operators, start to build solutions which are also consumed in an credit model, in a usage model, but also API-based. Yeah? And with that in mind, you see that no matter if it's low-level infrastructure, all the way to high-level services, you consume these via APIs, and you need a tool to make sure that you can leverage all of that, and preferably in a consistent way. Yeah? And that's where we think with Pulumi we have a solution for you. The reason for that, in that growth, is where you see the legacy tools from 10, 15 years ago. Well, where are they now in talking to APIs? They served a different purpose. They served that purpose well, by the way. So I'm not going to crack on any of these tools. They brought us where we are now. Yeah? And I still credit every originator of every of these tools and companies built around that for the work they did. But times are changing. Everything becomes much more complex. So that means that we need much more powerful tools. So during the presentation, I'm going to start with going from getting started all the way to sort of for you building a first full environment, growing your portfolio with more services, including all of the security aspects into it, and then growing your company. And growing your company at that moment is when your company is really growing with more teams and all of that, how can one maybe platform team serve a lot of development teams in with a solution but in a self-service model. So the first thing is understanding the product and the power of the product. And in this way, I'm going to really start off with, first of all, showing where we can, what we can automate with Pulumi. So on one hand, we have a lot of cloud and infrastructure providers. Yeah? All of these technologies can be configured and managed by Pulumi. But we do that with, by use of programming languages. So we don't have any domain-specific language, any YAML templating, although we do support YAML. But we give you the option, let's say, to leverage your programming language that you already are used to in your company. Core features of Pulumi, as I mentioned here, any cloud, any language. We do state management, meaning you can run a program, you set up infrastructure, and we keep track of what is already set up, because on subsequent runs, we do just a difference calculation and only make changes according how your program, your infrastructure program changed. Secrets management is integrated, so you can have configuration as input to a certain infrastructure, but also secrets management is first class, so we encrypt all your secrets so that you can even have these encrypted secrets. You can commit them to Git, and the key is somewhere else, the encryption decryption key. Yeah. Guaranteed preview plans, so even if we also have a preview phase that you can run, you can save the preview and then rerun that without the source at hand. And then a number of things which are coming from our paid offering, CI/CD integrations out of the box on our platform, full REST API, automation API, and then all the dashboards and resource reports. During the talk, I'm gonna highlight where our paid offering comes into the picture, but most of the talk goes about our open source offering. So, to understand how Pulumi works, just a short diagram on how the architecture of Pulumi is. So in the center, we have the CLI with the engine. So if you run Pulumi up, you start that engine and you start at that moment, Pulumi at that moment starts a language host. I mentioned that we can allow you to write infrastructure as code in different programming languages. Well, we only have a project descriptor file which points to this is the language runtime you have to start, and together with the full installation of the open source offering come a number of additional binaries who know how to start and communicate back with any of the different runtimes. Runtimes being Node.js, C#, a .NET runtime, Python, Go, and we also have for an easy startup also a YAML language runtime. Once the language host then evaluates the program, then it communicates using the providers to really create the resources on the respective technologies. Yeah? So that's at a glance the architecture, and during the presentation I come back to that because that's also how we become and are able to be so extensible. Because if we add additional features, well, these are all different plugins. So a language runtime is launched by a language plugin. Yeah? The provider plugins are resource plugins, but we still have other plugin types as well, and I come to that later. So to start off, you develop your infrastructure as code program, and what you have then is the program here, where in the code you create a number of resources, and sometimes you say, okay, I'm taking an output property from this resource once it's created, and that value needs to be passed as an input for subsequent resources, and so on and so on. Then you only have your code. You don't have any infrastructure yet. So how can you use that application then to set up multiple parallel environments, for example? Well, you create subsequent stacks. So in this case, I'm using, for example, the name dev, QA, and production as 3 different stacks where, for example, I test first in development, I promote to QA environment, and then I go to the production environment. With each of these stacks, that's actually the place where we store the state. So think about stack, well, then you think about the state of that stack which goes along with it. So that's how Pulumi keeps track on each of these different environments, what has already been set up. And if you afterwards change your program, then it can calculate the difference and it will only apply the changes, let's say, to that environment. So, small example, I took TypeScript as an example here. So at that moment, what you see is, first of all, I import an NPM package, Pulumi AWS, and from that SDK, yeah, we have all of the resource types that Amazon Web Services offer as types in an NPM package. So which makes that if you have an intelligent development environment, then you can have full code completion on all the properties with respective types and the proper nesting of types, etc., etc. So here, for example, I'm creating a security group with one embedded ingress rule. So I give it a Pulumi name, yeah, and the context is in Pulumi. No matter which provider you're using, you will always have overall 3 big arguments. The first is the Pulumi name, how we keep track of that resource in the state. Then we pass it some input properties, and it starts with a description. We have 2 input properties here, the second one being a collection, and this is one rule added as to that collection in the security group. So if we run that, the first thing which will happen is that we start that language host. Language host runs this program and sends back over a local gRPC connection that the security group with these properties needs to be created. Our engine then goes along and says, that type starts with AWS, so I start with launching the Pulumi provider, that resource plugin, which is a separate binary. At that moment, our engine says, okay, I compared that to the state, and there has been, nothing was set up before, so I have an empty state. At that moment, that means I trigger a create request to the Pulumi provider to create that security group. After the actual security group has been created, all the details of that security group are stored in the state, respective to that stack. So each of the stacks has separate state, and no pollution, let's say, from one environment to another can happen at that moment. That's the first run. But if we go to the second run, so a colleague of yours comes along and says, okay, let me check if my infrastructure is really up to date according to my sources, and it runs it, and your colleague runs it again and has access to that shared state. Then at that moment, same thing happens. Language host starts, runs that program, and sends the requests for these resources back to the CLI and the engine. Engine says, okay, I start. Now I already have an additional state. I get an identifier, the real identifier from Amazon, and I now do a check request to make sure if on the cloud that resource is still there. And based on the outcome of that, it's either, somebody might have deleted it manually, well, then it will be recreated. If it's still there, nothing will happen. And at that moment, we were done. Now, the nice thing, and that's one of the core things on Pulumi that you have to understand, is how can you model dependencies between resources? So I mentioned before, you can create a resource and take an output property, pass that in as an input for the next resource. So how do we do that? For example, we can run this and say, okay, I'm creating, I take a name for a security group, I create that same security group, give it that name, and then I create an EC2 instance and I link it to I link the VPC security group IDs to this existing security group. Now, what you see here is I'm using this constant type, a constant string in TypeScript, and I pass that as inputs here and here. But nowhere is there a relationship at the moment yet between the security group and the instance. So if we run this, well, language host, that sends back the request for both of the resources to the engine. Engine says, okay, I have empty state, so it starts the provider and sends the create request for both of these resource types at the same time. And what do you get? Boom, it fails. And this is because of timing. The timing is that the security group and the instance the requests are sent concurrently to AWS. And at that moment, if the security group is not yet created, well, then the instance can't link to it. So how do you solve that? Well, that's where in Pulumi, in all of our languages, as part of our core SDK, we added the concept of inputs and outputs. So how do you do a revised example? So that constant is gone at the top. I also removed the name from the security group, which you had here at the top. But what I did now at the bottom is using an output property called name from the security group. And by taking an output, any property, from one resource and linking that to another, I sort of make a connection between these two resources. That's the information now sent to the engine, and the engine at that moment understands there is a connection. So again, language host, information sent over, but here now in this chain, there is information that there is a correlation between the two. So given empty state, I get, okay, provider is started, security group request create is sent, but now Pulumi is waiting until the security group has been created before the create of the instance happens. And at that moment, Pulumi will pass in the actual name of the security group to the instance. Now, you would probably say, okay, but isn't that just that same string? Well, no. We apply one thing to any resource, and we call that auto-naming. Yeah? If you take the name, the Pulumi name of your resource, we append the suffix there, and that allows us, if you have resources on the cloud which you can't update, but you have to make a new version, and sometimes you have that, yeah? That allows us to create a replacement resource, rewire all subsequent resources before we delete the old one, yeah? Which allows you for a non-breaking upgrade of infrastructure. Yeah? So if you see Pulumi doing that and you continue, my advice is don't turn that off. Yeah? If what I did in the previous run by passing the explicit name here, at that moment I turned off auto-naming. Yeah? Because then I really say it needs to be that name. There are cases where you do that. For example, bucket naming sometimes needs to have that. But in most cases, it rather helps you than annoys you. Yeah? Although, yeah, a lot of people don't like that suffix to their resource names. But that's another thing. So at that moment, here we see a proper ordering of resources in a program. And now, yeah, now you have these basics, you can add more and more and more resources. And if there is any relation, just use an output from one resource and you have pass that in as input. And by that, you see that Pulumi will do the proper ordering. And there actually comes the magic then. We always talk, and definitely as software developers, we talk about imperative programming languages and declarative model. And here you see, because we have different runtimes, in a way, the imperative aspect of using programming language is here. And that, in the end, is an imperative way of building a declarative resource graph for our engine. If you understand that, you have, let's say, most of what Pulumi is about, you have that and you can fly. And that's how the reason for modeling that in regular programming languages is because of that complexity I pointed in the beginning. Yeah? The amount of infrastructure that any operations person or developer has to manage in these days is multifold compared to years ago. Yeah? And if you want to drive the creation of resources, yeah? Because this is code, that means if I need to set up infrastructure for each of my single tenant customers, for example, well, I can wire in an NPM package, which is a database driver, read my database information, and loop over every row of my database and create infrastructure. How easy is that? So, next thing is actually building up from there your first full environment. So I showed you one small program. One small program, but now you want to actually build something like this. You want 3 different full environments where you model part of your network. Maybe you have a Kubernetes cluster and you deploy a lot of services. Yeah. From here, actually, you can say, no, just a minute. So I said before you have your program, so for example, this responds to your program, and I set up multiple stacks for that with different names. But then I have a cluster, for example, cluster program setting up a fully hardened down Kubernetes cluster on my cloud provider. And from there, actually, you deploy services. Now, I talked about inputs and outputs to resources, but how can I, for each of my environments, provide inputs to that whole program? Well, one of the cases is if you have a stack created, you can have a corresponding Pulumi stack config file, and that will be in the root of your project with the name of your stack here in the middle. So Pulumi dot the name of your stack, and then YAML, for example, that could be Pulumi dev YAML, and in there you have a structure like this where both the providers can be configured as well as your own program. And so this is YAML as configuration being the input to your full program, but how do you access that then in your application? Well, we have also in our core SDK functions where you can just say new config, and then you do a get or require, and you give it the name of the key. So if I do a require for security group, I get WebSG as the value back, and that I can pass then into as inputs to any of my resources. Yeah. Structured configuration supported, meaning that this file can contain lists and maps, and if you have, for example, JSON deserializing, if you know a bit of that, all of a sudden I worked with TypeScript, so if I define a TypeScript interface in one call, I can read a full object back as a proper type, meanwhile validating that all the information is there, and if not, then Pulumi will complain that I'm expecting a number of properties and some of them weren't there. Now, that was the input side. Now, if I had that network layer, for example, and I need to pass information out, the actual VPC ID, for example, so that I can deploy my Kubernetes cluster in the stack above it. Well, the first thing I need, for example, is to make sure that some of these real identifiers, that I can have access to that. So that I can do with stack outputs. And given the TypeScript example, and here it's a bit different in all of the different programming languages, but in TypeScript, for example, you just export a value the TypeScript way. Yeah? With export const, you give it a name, and you provide one of these outputs from one or more of these resources you created. So for example, for this instance, I'm exporting the public IP address and its public DNS name. So at that moment, I can grab these two values and make sure that I can read these from another stack. Now comes in the end then that part, how do we read that from the other stack? Well, here I'm, for example, in another program, another stack, and I want from my first stack to read these values. So the first thing I do at that moment is, again, from our core application, from our core SDKs, you create a stack reference and point it to the name of your stack. The full stack is always the organization name, your project name, and then the name of your stack. That's a fully qualified stack name. And at that moment, you have access to all the stack outputs. And then again, with get or require, you give that key and you have access to the value. And from there, for example, you can use that security group ID in one as an input to adding an additional security group rule. Yeah? So that's how you can pass information from one stack to the other. If you then have to construct and layer, then comes, what do I group together? First of all, for example, on the network layer, when I set up my VPC, it's possible I create a standard VPC security group for outgoing traffic, in the beginning empty. Now, once you go further, I can say, okay, if I deploy my cluster using a stack reference, I will add a security group rule, yeah, specific for cluster. Suppose Kubernetes, for example, needs definitely access to DNS, so probably you open up port 53 for DNS. So at that moment, you say, okay, as part of my cluster deployment, I will open up port 53 and add that to that security group. And we can go on. Yeah. Next thing is that also my cluster can have some cluster-specific security group, initially empty, and I do that at that moment. Now, you can wonder, security groups, isn't that at that moment network-related? Should not everything be done at the network level then? Well, you could argue yes, but on the other hand, there are a number of ways how you can group things together, and I always favor the lifecycle model. One of the things that I learned over time is by grouping resources together that need to be deployed together, but more importantly, undeployed together, you don't leave things open to the world. Yeah? So if you deploy a service or anything and that thing needs more network permissions, I have the rules for the network, or for similar setups, I always deploy that together with the resource at hand, because if I undeploy that from the same program, I don't leave anything open and breachable security-wise. There are a number of patterns around that, and for that, I can point you to the book Infrastructure as Code, 2nd edition from Keith Morris. So somewhere around chapter 9 or 10, I think, there are 5 or 6 patterns he describes on how you can bundle resources together. Another angle, which I also think is quite valuable, is the blast radius. Yeah? So if you deploy an application service, do you deploy the database that that service deploys to in the same application, yes or no? Typically, I don't do that. What I do is I deploy the database separately, and I only add permissions to have access to that database. But if I fail something in my application deployment, it can't corrupt my database deployment. Yeah? So that's how you sort of can continue with saying, okay, as I deploy a service can still add that specific service, for example, might need outgoing internet access, so it adds an additional rule for itself, but on the other hand, it also needs some additional rules for cluster access, cross-service or whatever. So that's how you grow from one program over multiple programs and wire the things up. And then, yeah, by giving consistent naming, you are building up a full environment in a layered approach with some best practices at hand. But now comes the thing that, definitely at the level of these application services, is that you start to get probably some code duplication. You see patterns emerge where if you deploy your application services, then there are some variations. Some services are stateless and process messages and don't need access to a database. But some other services have an ingress endpoint, talk to a database, but don't talk to queues. So there you see a number of patterns, and you want to, let's say, group the resources which need to go together in such a deployment together, and probably have some minor configurability on each of these patterns. So there we start to build components. And components are nothing more than just a class, where in the class we create the resources like I just shown, with the only difference that we set the parent of the resource to the enclosing component. Yeah? And this aspect, if you're not familiar with TypeScript, that's just the way how you point to the enclosing object. How does this run? Well, at that moment, um, all of this code in a single language component, if you just develop it, well, that runs in the language host, so it sends the network component together with its children resources all back to the engine. Engine says, okay, component is sort of just a container, nothing to really create for that. But the resources then are again AWS, so I start the AWS provider, and these are create requests given there is no state, so same thing as before. With the only difference that if you look in our platform, for example, you will see that component being visualized with its child resources. There are a few other technicalities around it, but that I'm going to leave for another talk or for further investigation for yourself. You can always come and ask me afterwards, by the way. Now, a component, of course, is not limited to having resources only from a single provider. So don't think that you, because I've shown here only 2 AWS resources, that I can't add anything else. So if, for example, you want to add already some Datadog specific observability stuff in that component, well, you can. But at that moment, the engine here will start 2 providers and send the proper requests to each of the providers. Now, growing even further, and that's again where our architecture and the plugin model comes in handy. We also have a way, given that we support multiple languages, to allow you to build your components in one language, but still have it consumed from any other language. And the easy part around that is because we cross the process boundary. These are local gRPC network requests. So what you have then is, given that same code, we can actually bundle that as a provider in its own way, complement that with what we call the Pulumi schema, which just describes, let's say, the available properties that we can send back over the wire protocol, and that only describes the not the internals, but the external shape of your component. So in this component class, I provide the network arguments. I'm only providing the CIDR input block. So in the Pulumi schema, the only thing you will see for your network component is that input CIDR block as a string. And once we have that Pulumi schema, we can just give you the whole build tooling, let's say, to generate from that Pulumi schema corresponding language SDKs so that anybody else can consume your component even from another language. So the fact that we have that gRPC protocol in between allows us to do that quite easily. And that's actually where even components we built ourselves for you are built that way. So we just offer the same tooling, nothing special, to you to build your own components or resource providers. So we can even bundle both types, single resources, for example, like the AWS provider, can be mixed in with all of the component niceties. So that's how then you get rid of your code duplication. And one thing I like to do always is then, if I have very well designed components, well, I let the development teams, for example, consume that with a few lines of YAML code, because the YAML language runtime at that moment is this one. It sends the request for the component, and then the engine will say, okay, let me launch that plugin binary. That code is evaluated here at that moment, and then the request for all the child resources is sent back to the engine. So it's a bit of back and forth over that local network connection, but at that moment, everything works just fluently across language boundaries. All right, we have that full environment. We built up a number of layers. We have set up multiple environments from all of that. But then comes our security team along and says, I'm not sure if everything has been set up correctly. I want some guarantees. And that's where we have policy as code. I talked about the pluggability, the extensibility of Pulumi. Well, policy as code, again, we have policy plugins which talk again to our engine. So if you run Pulumi even in open source, because all of this, what I show so far, is all open source. Even the policy as code is open source. You can write policies and here we have only TypeScript and Python at the moment fully covered, but you can write your policies in each of these languages for any and validate all the inputs and outputs and settings of every resource you use in your setup. So, small example. So, the reason actually is that we want to maintain security across all the clouds and all the applications, and how does such a policy look like? So we start off with creating, again from code, a policy pack object, we give it a name, and we have a collection, again with the square brackets, it should be highlighted here as well, a collection of more than one rules. So here we have two rules. First of all, we give it a technical name, and we have a more liberal, the human readable description. So in this case, we want to prevent that our S3 buckets have public read access, and second, that also for security groups, nowhere is there an ingress rule, for example, with fully public read access. Then we say, okay, is this to be enforced, or is it just advisory? So advisory means we will generate a warning. If it's mandatory, we will really block the deployment and prevent that you go further, even setting up and have a warning afterwards. And then comes the fact how we implement it. So in the setup of a rule, we have the validate resource, where you provide a callback function. And in that callback function, you can do anything you like, evaluate a single resource, evaluate a combination of multiple resources to find out whether you comply or not. And that's, now typically in the beginning you want to validate certain properties of your resources. So we provided a utility function called validate resource of type. You provided one of these types, and then you get all the functions to your, all the input properties, let's say, to your availability. And you have again here a callback, a function handle that you can use to report back whether or not you are in violation. So if you want to do the report violation, use that function, pass it a string, and in the end, that's how you interface back the message of violation back to Pulumi. These are, this is then the full setup. Again, this comes from two of our core libraries, fully open source, done. A few reasons why you would be doing such rules is, first of all, data protection. Here, for example, I'm going to enable storage versioning on cloud buckets, making that mandatory. Second, cost optimization. So here I want to, for example, limit the bucket logs to 45 days and not more than that. And also reliability, for example, that any Kubernetes deployment is done with at least 3 replicas. So, and on top of that, you're free to build any additional practices that you like. So if you want to prevent people just launching individual pods on a Kubernetes cluster without having a service, without having a deployment or a daemon set, well, that's, for example, how you can also prevent people from doing that. Last month, we added something new to that. So rather than only reporting on warning or error, you can replace that validate resource with the transform resource, and you can provide the function really, and at the meantime, just updating that value already. So why just block only if you can immediately update to the correct setting? And at the bottom, for example, you see such remediation in action, where we won't do it silently. We will still inform you of what these rules have been updating. So this is already a new thing since last month. And this is from our cloud offering, where policy as code is an open source thing. The enforcement in a full environment, yeah, that people can't bypass, that's from our paid offering. And then you will be able to publish policy packs, assign stacks to that, and if people run Pulumi on that stack, they will have that policy pack applied immediately and verified on every run, whether that's from a local development workstation or, for example, on CI. No problem with that. This is how a run looks like. At the bottom here, you see then how from which policy pack the rule was mandatory and the message being given for further investigation. Even if in the code I showed you mandatory, for example, for a development stack, you want to say, okay, I know that we still have to fix things, but let the developers go through for a minute. Well, at that moment, you can still overrule the mandatory setting on our platform and say, okay, make it advisory temporarily, and everything will be changed to warning. But developers at that moment can still test at that moment already certain infrastructure and update the infrastructure code later. New thing, before you start off writing all these policies yourself, published a number of pre-made libraries in the open source related to a number of security frameworks. So if your company has anything related to auditing PCI DSS, ISO 27001, SOC 2 or CIS, we already have for the big three cloud providers a pre-made collection of rules that you can just enable. Yeah? And enabling these rules is as easy as this. So again, we have that policy pack with the name. We have to provide a collection of policies, but here we made an additional utility class that automatically selects matching rules based on the tags which are on all of these individual rules in the libraries we published. So feel free to use these to your availability and report anything back that you are missing or that you think might be an improvement to these rules. We definitely want to hear from you. And then we come to that last part, growing the company. Yeah? So you already evolved from bootstrapping with Pulumi, building the different environments. Security team are satisfied now as well with all of the security at stake, angle fulfilled. More and more development teams start to work with you as a platform team. And no, we don't. You no longer want to work ticketing based, and I want to create a self-service model. So now we come actually into that level of platform engineering. And this is actually now a diagram we remade about all the different Pulumi capabilities that we currently have. Yeah. So I started off with Pulumi infrastructure as code, yeah, also with the components live here. I talked about policy as code, yeah, which is on the security plane, but you see that we have a lot more. Yeah. I mentioned that you can run Pulumi in CI/CD, but as part of our paid offering, we also have Pulumi deployments, which is also a REST API-enabled way to trigger deployments of all of your code bases to your liking. Yeah. Given it's a REST API, we bundled that with Pulumi Automation API. We already had Pulumi Automation API with support for local workspace. And what does that mean? Automation API gives you an SDK to, let's say, integrate running Pulumi using code, yeah, in a bigger setup, like a workflow engine. Yeah? So that means rather than doing CLI commands Pulumi up, somewhere in your code you first create a workspace object and then you invoke the up method on that workspace or stack, and you have really in code the outcome as an error, and etc., etc. So if you're using, for example, temporal as a workflow engine, which I very like, by the way, that's also workflow as code with steps implemented as code. Well, this goes hand in hand very easily because you implement your step where from a workflow step, You bundle that with automation API, and all of a sudden, as part of your workflow, you have a step implemented where you are running a part of your infrastructure. But with deployments at that moment, so the local workspace needed a local Pulumi CLI at the moment, because we also interface using that gRPC protocol to the engine to run and drive Pulumi. Now with deployments and a REST API at hand, we added in that SDK a remote workspace support. So that means remote workspace means that just calls into that REST API, a deployment starts, we monitor the outcome of that and give you the result back again in that same code. So the only difference is you switch from local workspace to remote, done. But we're not there yet. Given that all of Pulumi and the creation of stacks and the deployments has a REST API, you can also leverage that at the top level as a developer control plane. So we have created our own developer portal, and what does that mean? It's only a small start, let's say, but we allow you to have private infrastructure templates that you can instantiate using our cloud portal and immediately hook Pulumi deployments to that. And so if your developers have access for development stacks to that cloud platform, they can immediately self-service model create a full infrastructure. Second, Backstage. Backstage is, and I was one of the co-authors of that, it came out of a hackathon project where in the beginning now we started with integrating also the same scaffolding of templates and having the view and the outcome of running an infrastructure deployment to once your people have access via the Backstage repository. And yeah, given everything is API and code, you can even still create your custom portal. So out of the box, our platform gives you create new project wizard. You can use a template. Here is a showcase of a repository-backed set of templates, and at that moment you can run and have that completely set up. Backstage, scaffolding, and the view. Yeah, you can come back to me afterwards for more information. But that's where we only have 2 integration points covered now, but we have ideas to have a lot more. And then ESC, but I think I'm running out of time because I'm going to skip this for a minute. But some closing thoughts and pointers if you want to get started. First, probably a lot of what I showed definitely at the beginning resembles Terraform. And one thing is, we migrate your Terraform to Pulumi with 2 simple commands. Yeah. So first of all, if you have your repository with your HCL code, you can run Pulumi convert from Terraform. You pick your language you want to have it converted to and an output folder, and we go. Yeah. Second is, and this is just released last month, if you also have the corresponding state file, you just create a new stack and say, import all the resources from the Terraform state, done. If you have Terraform, in this conversion, you either have even the distinction between a program or a module. If the HCL sources you have here are modules, we convert that into component resources as I shown before. That's one. Second, finding help, of course. First of all, documentation, the registry with all the different packages you can find for resources to set up, and our community Slack. Yeah. It might be not completely visible, but if you go to our main website, the links to the documentation, the registry, and our AI, that is at the top of our website. And one short thing about our AI, this is a model trained by ourselves with all of the documentation from our registry, from our own website. And at the bottom, for example, here, you pick the language you're interested in, even Terraform. you write, create me a program which sets up an EKS cluster on Amazon, for example, and our AI will give you definition, copyable code. You have the copy icon here, and this should be able to get you up and running quite fast. But I'm not going to delve into further into the AI part, because Thomas, the next speaker, will tell you all about that. The only thing is, thank you for coming, thank you for listening in, and have a nice day at the conference.